Hello, everybody. And actually, I already saw that a couple of guys asked me where part of my presentation name, Birds of Feather. And actually, Birds of Feather is type of the presentation on the CNCF. This means that it should be like more discussion. And if you have any questions, we can discuss it later at the end of the presentation, or you can try to interrupt me. Okay. My name is Igor Khapov. I am a developer in the Moscow Science and Technology Center. It is a development lab, and traditionally we are creating IBM software. We participated in the different projects related to the cloud, to on-premises solution, and so on. One of my last projects is Watson Studio. Watson Studio is a cloud and on-premise solution to simplify data scientist day. We have Jupyter, Zeppelin, RStudio. We work with GPU devices, and the whole infrastructure works on top of the Kubernetes. And when we created this infrastructure, we collected some issues. For example, the first issue was that when we are providing possibility to use GPU devices with Jupyter Notebook, and when we are using Kubernetes, you know that GPU is still in the beta state, and you couldn't share GPU device between different pods. It was a problem, and we started to think how to solve this issue. And another one issue was how to automatically understand if client still use GPU, because we just attach GPU device, and in the Jupyter Notebook user interface, user start line by line code, and for some cases it's reasonable to have GPU device, for some cases not. After that, I decided to do small research if serverless technologies can help to solve these issues. Some common slide. And actually, when we are talking about serverless technology, this means that we are talking about design where we have some backend code hosted in the cloud, hosted on premises, and we have some functions. Traditionally, this function has input, has output, contains stateless, working in the stateless, and traditionally it is hardware agnostic. IBM joined to this history about 4 years ago, and actually right now there are a lot of serverless frameworks exist. There are a lot of cloud serverless platforms. There are a lot of solutions which can be installed on premises. IBM contribute to the OpenWhisk projects. It's under Apache license, and it's written on the Scala. And today demo, I will show you how I use it for my use cases. Each time when I am working with different development teams, when I am talking with the clients, everybody asks me what is the best use cases to use serverless. It is the first question. And I try to collect it all use cases which is related to the serverless technologies on this slide. And today I will talk more about the data science applicable to the serverless. Okay, and my story in the serverless was began 2 years ago, and I participated in the hackathon in the Bucharest, and the company which organized this hackathon was a newspaper company, and the goal was to find out fake news. We have a feed of the news, and we should determine if it's fake or not. And during the hackathon, we created Node.js application. We created, who knows what CloudNat means? CloudNat, it's CouchDB, but hosted in the cloud. It was a separated company, but IBM bought it maybe 5 years ago. If you will see CloudNat, this means it can be replaced by CouchDB. Okay, and we decided to use serverless technologies. Yulia from my team implemented the solution where we get the events if we have a new news in the feed, and we created a function which just collects the topic, collects some statistic information, and after that we put everything to the Watson Studio. Watson Studio contains some model management, model training information. For hackathon, we just create an endpoint for our models, and we parse the whole article to machine learning. And if we are talking about serverless, and if we are talking about OpenWhisk, it's event-driven. What that means? We have packages which can provide different events. Based on these events, it can be collected by the triggers. And we have a set of rules which determine which function should be started and if function should be started. After that, we have an action. In our case, it will be Docker container hosted on premises. And the result of the function is JSON, which will be stored in the CouchDB. Let's look at the architecture of its common architecture of the OpenWhisk. We have Nginx. We have controller responsible to monitor all invokers for scheduling the function between different clusters or invokers. I'm talking about clusters and invokers. Today I will show a demo where we will use a single Kubernetes cluster. A single Kubernetes cluster contains only one invoker. This means that this invoker tied with the Kubernetes scheduler and can invoke a lot of functions inside the Kubernetes. But if we want, we can attach Mesos, we can attach Docker and other cluster systems to this architecture. And all results will be stored to the CouchDB. I know about some experiments when people was not satisfied to store all results in JSON format to the CouchDB. For that purpose, we can replace the CouchDB with an in-memory database. It is not easy, but possible. And of course, we have a Kafka, which will distribute the actions to the different invokers. The only one point that we also should have a Docker registry which will provide Docker containers to all this infrastructure. Okay, and actually OpenWhisk Git projects contains a lot of information collected in a lot of projects. The first portion regarding platform, we have OpenWhisk itself written in Scala. We have command line interface. We have API gateway, and we have catalog where we can install our packages. We also have a lot of runtimes. This means that if you want to write down a function based on the Node.js, Python, and other languages, you can just get this runtime and use it. But why I decided to use OpenWhisk for my use case? Because there is a possibility to create your own Docker container and integrate all libraries inside this Docker container. We also have a lot of tooling. For example, we can deploy OpenWhisk using Ansible. We have a Helm charts to deploy the whole system OpenWhisk on top of the Kubernetes. It can be installed on the virtual machine, on the hardware, and so on and so on. And of course, you can add invokers wherever you want. We have a set of packages. Packages mean that you can create your own package and consume and produce events from your own application. It can be just curl post zaпрос, it can be gRPC, it can be any triggers, you can do whatever you want. And of course, we have a lot of SDK to integrate action creation, action invocation from the code. Okay, after that, I decided to investigate what is use cases applicable to the data science from serverless area. The first one, what we did during the hackathon, it's just preprocessing the data. It's really suitable and the common feature of the serverless when we just preprocess the data and after that start maybe data science, store to the database and so on and so on. I find out a team from IBM Zurich which tried to create something. From my opinion, they're trying to create a new MapReduce based on the serverless technologies. But they tried to have a state for the functions. Of course, functions should be multi-tenancy, and it is a really problem to store the state if you have absolutely stateless technologies. For that purpose, they decided to use Apache Grail. They created executors which work with different languages, and they created a driver which tried to execute functions closer to the data, closer to the Apache Grail, and they are trying to move the data in the Apache Grail closer to the function. In my case, I decided to create something like a mixed infrastructure on top of the Kubernetes, pure Docker, with different architecture and with different hardware. Traditional way for serverless is use hardware agnostic way. This means that when users start a function, for him it doesn't matter where it will be started. But if we are talking about data science, it is really important to have enough resources, to have GPU resources, and so on and so on. To show a demo today, I decided to use simple design. We have CloudNat. We have a trigger which will invoke the Jupyter code with model training, and we have a code which will test the model. I'm not a data scientist. I'm more from Kubernetes area, from infrastructure layer, and I just go to my colleagues and ask if they already have some Python code which trains the model, which starts for that. And the problem was that all Jupyter notebooks which they created contains something like a mesh of the lines, and there is no any state. And to solve this issue, I have to use TensorFlow state, and it's possible to store the state in the TensorFlow, put it on the CloudNat or CouchDB or maybe object storage, and after that restore it. It is slow. But for some use cases, when you should support multiple versions of the models, it's reasonable. On this slide, I draw the target architecture, which I want to create. It's not absolutely ready. We have API gateway. We have the functions which is responsible to collect the data from different sources. We have a function which is responsible to train the model. And we have something like checkpoints which store the state of the model to the different in-memory database, to the object storage, and so on. It depends on the use case, and it depends on which client want to have such infrastructure. And what I really like that using functions, we can implement retrain model based on the OpenWhisk event if something was changed. For example, if we have a new feed for retraining the data, which we just get this event, retrain the model, store the state, and after that deploy the production model. Okay, and actually I work with GPU devices on top of the power architecture. Who know what power architecture means? A couple of guys. And actually, it's something like Raspberry Pi, but open source technology for architecture, which contains a lot of benefits for some use cases. This is speech not about power, but you should understand that it is absolutely different architecture, and you should build source code and Docker images separately. And actually, I decided to use Power for model training because it's quite powerful. I decided to use X architecture for common goals, and I decided to use Jetson devices to run the model. Who know what Jetson device? Yeah, and actually Jetson device, it's NVIDIA platform, something like a Raspberry Pi, but with integrated GPU device. I bought Jetson Nano and try to integrate it in the cluster right now. This means that it is quite cheap device. Jetson Nano price about $100, but it's with GPU. And if you want to analyze the video stream, you shouldn't stream the whole video to the internet, to the cloud. You can analyze this video in place. Okay, and if I have a mesh of the architecture, and if I want to create Docker images for which will be started on the all of this architecture, I should create Docker manifest. Who heard about Docker Manifest? Okay, and actually Docker Manifest provide us possibility to build Docker images for X architecture, for Power architecture, for ARM architecture, and after that create something like a virtual Docker image which will aggregate all these architectures containers, images. And when Docker will try to pull these Docker images, the system automatically understands which architecture you are using, and you will get the correct Docker image. Okay, of course, it is not working from the box, from the OpenWhisk, because of it doesn't contain possibility to specify the node where you want to start your function. And as I already mentioned, it's written in Scala. And I was a Java developer 5 years ago, and when I changed the codes, I realized why I decided to use Node.js, Python, and so on. There are a lot of level of abstraction, and OpenWhisk work with methods, with Docker, with Kubernetes. This means that I should change all level of abstraction, and I should create stubs for all of these clusters. Let's look how it works. Okay, 1 second. Let me switch. Okay, let's connect to my cluster. Okay, I have 3 nodes in this cluster. The master on top of the X architecture, and I have 2 power workers. But I enable scheduling for the master, which will mean that we will be able to start function on the 2 architecture, power and X architecture. Okay, and I want to show you also how I did that. Okay, I already mentioned that we are able to create customized actions based on the Docker image. Of course, if I am using multiple architecture, I should build it from scratch. In the GitHub, I find out a Docker file with the name Docker Skeleton. Docker Skeleton provides us possibility to work with OpenWhisk. And yeah, this file. And actually, you can use any base image, but it should contain the Flask, and it should contain action proxy. Action proxy just a simple implementation of what function should do. And if we will go to the source code and close what we do not need, it contains information about how we should init this function. This means that when we create the function, init function will be started inside the Docker container. For example, if you want to pre-warm your container to be ready for input and attach some additional resources, it should be done on the init state. And we have run, and this function will be started when we are invoking the function. Okay, and I created a skeleton Docker image, and you should do that only one time. And if you are using only X architecture, you can just download it from the Docker Hub. After that, you can put wherever you want inside this Docker container. For example, I just install some Python packages and put my data science logic inside it. And of course, build it. Okay, and as a result, I have a couple of Docker images. I have a Docker image for Power architecture, for X architecture, and the lattice, it's not a traditional Docker image, it's manifest, which point me to both of the images. I pushed it my own registry, and in this cluster, I also have installed OpenWhisk. For example, you can have separated installation of the OpenWhisk, and you can install separated clusters for invokers, but I mixed infrastructure to reduce some resources. I install it in the separated namespace OpenWhisk. Okay, as you remember picture, we have API gateway here. We have alarm provider, which listening different events. We have CouchDB and CloudNet provider, which contains the created functions and results of that. We contain the controller, which decide where should we start the function, and if we have free function, or should we invoke some additional pods if we overloaded. Of course, we have a Kafka, or we have a Nginx, we have VSK admin for some administrative function with Node.js. And actually here we have a couple of pre-warmed functions for Node.js. Okay, right now we want to create our own function based on the Docker image. I installed VSK CLI to do that. VSK action. It is the name of the function. After that, we should specify Docker. I do not specify Power or X architecture because I need to get the correct images for each of the architecture. Okay, and if we will go right now to the OpenWhisk namespace, right now nothing will happen because I do not specify that I require pre-warm container. This means that container will be created only after the first invocation of the function. And after that, the action was already created, and I want to invoke it. Okay. It do not provide any results because I do not wait it, but it provides the activation ID, and I will be able to get the results after that. And if we will go to the namespace, we see that on the Power node, the container was created. And we can get the results of the activation. Using the ID. Okay. For the results of this function, I'm storing results to the separated environment. I'm just showing which architecture I used to start this function. If you have a small piece of data which your function should produce, or if you want to create a chain of functions, you can, for example, create a lot of JSON attributes and provide it from one function to another function to store to the database and so on. And after that, I want to relocate this function. I want to create the function on the different architecture. Based on the same Docker image. I want to reroute it. And I'm just using the same command, but create with different name. Okay, let's go to see what we have in the cluster right now. Okay, as you see, the first function have pre-warm state on the Power architecture, and the second function based on the X architecture, on the master. And of course, we can get results. and it is based on the X architecture. It will provide us possibility not only to share, to use different architecture in the same cluster. For example, if you are using the GPU devices, you can attach Invoker directly to the Docker. And in that case, all actions which will be started using this Invoker will be able to share GPU devices. And it will provide possibility to increase the utilization of the GPU devices, of the FPGA, and so on and so on. Let's return to my presentation. One second. Okay, and why I'm doing that? Because I am not absolutely satisfied how we are utilizing our resources. For example, if I want to create a pipeline for my data scientist, I should have dedicated resources for this team. And this team could not be sharded with different departments, because it will be really difficult to share GPU devices to collect the whole information. But if we will try to apply the serverless technologies for these use cases, we can get more results. For example, it's a real problem to create a function collocated to your data storage. In the IBM, we have a project where all data stored in the Poughkeepsie. But I have no enough resources in Poughkeepsie to start all data science logic to analyze these results. And I have to start it maybe in London, in Amsterdam, and it's quite big delay to download this data to another one region, to analyze it, upload results, and so on and so on. For some functions, it is really important to have more resources. Traditionally, for each function, we have timeout, we have limitation, for example, that function should be completed in 1 minute, that it should be only with 1 gigabyte of RAM, and so on and so on. And to summarize everything, I suppose to understand if you really need on-premise servers, you should have a lot of in-company developers, because it requires a lot of development, a lot of integration, a lot of things. And you should understand that you will be able to create functions which will be started not in the hardware agnostic way. And you will get benefits which I already described on the previous slide. You can improve utilization of your resources, especially GPU devices and maybe some SSD disk and so on and so on. Of course, it is really important to create a good pipeline of the data science. And when I created this project, I worked with a data scientist, and they like this project because they have to split their huge pipeline into small pieces. And it is quite easy to support small pieces of the data science code than to have a mesh of everything. And of course, you should have a time to implement everything, because right now I have no any idea which framework supported from the box. But I hope to upstream what I did to the OpenWhisk, and hope it will be available for everybody. Thank you very much. If you have any questions.
Any question? No one? You have one.
Thank you for your talk. Did you know any cases, when it was
used in production or near production scenarios?
It is the second question when everybody asks me. And actually, I know one case. Right now, we are deciding which architecture to use for some video analytics services. And we have two options. The first option is to use fog computing. It will be something like an edge when we will have a lot of devices directly to the video cameras to analyze the video stream, and we will have cloud solution which will train the model. And the second solution, which already partly implemented and will be in the production, I suppose, is to use serverless, not to the whole data cycle, but just to run video analytics. It's already built and prepared Docker containers, and we just should start it on X architecture.
Okay, thank you.
You're welcome. Okay, thank you everybody.